Hey guys, thanks for coming back for part 2 of the plant tissue culture series. And in the last video, I outlined some of the parameters for our experiment. And that was we need to have controlled temperature and controlled lighting, and no major fluctuations in those two values to successfully clone plants. And my solution to that was to build the automated growing chamber. And I went over some of the electronics that I used to pull it off, at least in my setup, and really the hardware of the whole system. And in this video, I'll be going over the software and really what makes it all actually work, the logic behind everything. So I love coding. It's what breathes life into projects. If you don't enjoy it, maybe you'll find something here that you haven't seen before, and you might find it kind of interesting. I'll also be going over some of the cloud servers that I use to store the data and to visualize it so I can check in on my little plants no matter where I'm at in the world. So that's pretty cool in itself. So stick around till the end if you want to see that. And enough of me talking, let's get into it. Okay, here is a quick overview of the code I have running on the Arduino Nano. There's actually two sets of code that's in this controller, and one set runs in the Nano, and then one set of code runs on the Wi-Fi module. I had to write a custom firmware for that, and it was just much easier to split the two up. I know I probably should have just used the Node MCU board, like an Arduino that has Wi-Fi built in. In hindsight, I should have done that, but that was my workaround, is having two different sets of code. So this is the main code, though. This is the one that you'll probably want to see if you're wanting to build something similar. So I'll do a very quick overview. The code's not terribly long, but it's kind of dry, so I don't want to spend too much time on it. I start off by importing all my libraries, setting up all my constants. Then I have a struct here that contains all of my sensor data. So it just made it easy so I can pass around this sensor data struct to different functions and then use the temperature data as I need, or the sensor data, excuse me, as I need. And let's see, this setup function, all of that does, this runs one time whenever the Arduino boots up, and that just sets what all the pins are supposed to do and initializes all of my sensors. And then I have this main loop here, void loop. So this thing runs over and over and over again on the Arduino. I believe it's every 30 or 40 milliseconds it loops through this. I can't remember the exact number, but something along those lines. And what this does is this is the main control for everything. This is one block of code, and then I have a ton of functions down here to try to simplify the logic. So my first if statement here, it updates the sensors at an interval. So I believe it's every 10 seconds or so, or maybe 5 seconds that the sensors get updated. And so that's what happens here. It calls a function that's called, I think it's update sensors. And then it updates that struct I talked about earlier. And then it checks if it needs to turn the lights on and off, depending on what time it is, what time it received from the real-time clock. And then if the lights do need to come on, it just calls this function that I wrote called lights on, or I think it's just called lights. And if you pass a value of 1, the lights turn on. Pass a value of 0, the lights turn off. Same thing here. You can see the lights turn off if the time says it needs to turn off. And this 30 and this 10 here, that's just a placeholder. I'll change it to something more elegant later, but this made it easy for me to see in the cloud whenever I send this light state value in. If it's 30, that means that the lights are on. If it's 10, that means the lights are off. And I'll show you that in a few minutes when I go to the cloud. And let's see, the last thing, every 20 seconds, the Wi-Fi gets updated, and it just sends all of the data over in a serial stream to the ESP module, and then that converts it into individual pieces of data that get sent to ThingSpeak. And that's the cloud server I'm using to store and view all of my data on the cloud. And then finally, this is the temperature control. It's very simple. Essentially, all it's saying is if the temperature is under 25 degrees, turn the heater on. If the temperature is over 27 degrees, turn the fan on. So that tries to keep the temperature between 25 and 27 degrees Celsius. And eventually, I would like to do a sensor fusion of the two temperature sensors I have in there, rather than just using one value. That way, I can try to make the controller a bit smarter just to make sure that both sensors are behaving as they should. But that's going to be a little later if I want to. And let's quickly go over the functions. The main one, so this is my update Wi-Fi function. And this just packs up all the data into one serial string and then sends it over to the Wi-Fi module. I believe it's every 10 seconds. And from that, the Wi-Fi module has its own set of firmware, and it gets sent up to ThingSpeak. That's the main one. I'm not going to go over every one of these functions. That's pretty dry. The only one that is special is this function here. This is from the struct that I made earlier, and this is where I update all my sensor readings. So this is where I get my humidity, I think it's temperature 1 is what I called it, yeah, temp 1, and then temp 2 is from that Bosch sensor I showed earlier, and I get the time, and pretty much it for the code. I can quickly, real quick, go over the custom firmware I have running on the ESP board. Again, it would be much easier just to use the Node MCU, but this is what works for me. So here's where I would put my ThingSpeak channel ID, my API key, and up here is my Wi-Fi SSID and my password. And then really all it does is I had to include the ThingSpeak library, and it makes it pretty straightforward. This listens for that string that I sent over with the Arduino. That's where all my data comes streaming in. And then that sends that to ThingSpeak. And this all runs, I think, like I said, about every 20 seconds. So now let's hop over to ThingSpeak so I can show you what the cloud looks like. Here is the ThingSpeak channel I have set up that listens for the data sent by the Wi-Fi module on the cloning chamber. And this is so I can view it. Start over. Here is the ThingSpeak channel I have set up for viewing the data sent by my Wi-Fi module. And I'll tell you what, this is pretty handy. I can see right here, let's see the temperature 1, temperature 2, the humidity, and the lights. That data is streaming in live. And I believe it's every 20 seconds or so. And you'll see data points popping up as we speak. And you can see data is streaming in less than a minute ago, so that's good, useful. Start over. Okay, here is the ThingSpeak channel I have set up that listens for the data sent by the Wi-Fi module on the cloning chamber. So about every 20 seconds or so, you'll see a data point popping up in these plots here. And there we go. We can see the temperature 2 just went up from 24 degrees to 25 degrees. And you can see right here, at last entry, less than a minute ago. And let's see, here's the lights value. So I can see that the lights are off right now. And the humidity is at 56%. And I don't think I have anything else down here. Yeah, nothing too exciting down there. But ThingSpeak, it's a pretty awesome free tool. I think it's ran by MathWorks, so it's pretty easy to use, and you can even easily plug it into a MATLAB account if you have one, and be able to do some pretty cool stats on it with the MATLAB program. If you have access to that, you don't need it, but it's nice to have. You can also plug a lot of other things into this. So this was just for cloud storage, but you can also use like an if then that server. So hey, if you plug it into that, you can like say have an email sent to you whenever these temperatures go out of a certain range, or you could have a text sent to you, something like that. But what I'm doing with it is having it to send to my phone, so I can view it live no matter really where I'm at in the world. And I'm going to take you over there right now so you can see exactly how I'm doing that. Okay, I wanted to show this real quick on my phone. One of the coolest features of having Wi-Fi on the growing chamber is I can stream the data to my phone through ThingSpeak. So I have this app here called ThingShow, and that connects up to ThingSpeak, and I can see the data live coming in. So really, no matter where I'm at in the world, I can check on how my little plants are doing. So this has actually already saved me one time. It was heating up too much because I had 2 powerful bulbs in there, but I was able to save them in time before it got too hot. So you can see down at the bottom, I have 3 boxes, and that's the temperature 1, temperature 2, and then the light indicator value. So remember, 10 means, for me, it means it's off, and if it's 30, that means it's on. So this is nighttime right now, so that means that the lights are off, which they should be. And I can open up the app real quick, and you can see the data streaming in live. And that's just a quick way to monitor my plants while I'm on the move. And that is it for the environmental chamber. I've been monitoring it for the past week or so now, and everything is working just fine. Data is being uploaded to the cloud okay. Temperature is holding fairly stable. I will say I will probably add another cooling fan inside the chamber, especially in the afternoon whenever it's a little bit warmer. That CFL bulb really heats up more than it should, and I get up to about 28 to 30 degrees sometimes. I think that's too hot, so I'm going to go ahead and add another cooling fan to try to keep the temperature down throughout the day. In the next video, I'm going to get into the actual tissue culture process itself, at least the one that I used, and get into the actual experiment we came here to see. So I'm going to go over the hormones that I used and the different cuttings I chose on the plants themselves, the actual tissue samples, and I can't wait to get into it. So I'll see you next time.